Spectrophotometry is an essential laboratory technology. It's important for water analysis in wastewater plants and surface waters. Further fields of application range from food and beverage industries to service, training, and research laboratories.
Chemical substances and matter found in aqueous solutions absorb light at specific wavelengths, depending on their chemical characteristics. A photometer is an instrument for accurate measurement of the absorbance behavior. If we look at the home screen, we can see possibilities to take readings for the concentration, absorbance, and transmission, plus special and multi-wavelength functions. We can also take spectrum readings and run kinetics. The basis for every photometric test is the absorbance and transmission reading. We can easily take a quick look at this. We simply put a water-filled cuvette in the instrument. Light passes through it freely. We observe that there is no absorbance and, switch to transmission, we see that there is 100% light penetration. This behavior changes in colored solution. Choosing a red solution, we take a reading at 525 nanometers. A reduction of almost 97% and nearly 1.5 units. The substance sort of traps the light in the cuvette. Absorbance and transmission readings can be used for qualitative analysis in production monitoring, for example. But how do we get from qualitative analysis to quantitative analysis? First, we need to run a spectrum. This means that we test the substance along the whole wavelength range and see a peak in this spectrum at 525 nanometers. Therefore, in order to determine the concentration of, in this case, nitrite, the ideal measuring wavelength is 525 nanometers. And now we draw a calibration curve like we used to in the past. Unknown sample concentrations can be determined by comparing the absorbance value of the sample with the calibration curve. This is a rather time-consuming procedure. Nowadays, a photometer is pre-programmed with calibration data and concentrations are calculated automatically. Using a modern cell test, I would now like to show how method data is stored in the programs of the device. Once the reading is completed, the screen shows the result, the wavelength being used, and the appropriate test. Here we can see the measuring range and citation. The units, which can be switched between milligram per liter, parts per million, or millimole. All of this data is programmed and stored in the photometer.
Modern photometers offer a multitude of functions for simple and comprehensive measurements as well as pre-programmed methods. Analytical quality assurance is only one of many examples.